So there's no video accompanying the introduction today, as I'm waiting for a new camera and today for the first time testing out my new microphone, which I hope will make a huge improvement. So if you're listening to this on YouTube, please feel free to let me know if the difference is in fact noticeable, or if you have any other suggestions to make major improvements to the production quality of the podcast. So with that said, on to today's guest. So today I'm speaking with Joey Newton of the YouTube channel That Chemist. Joey is a relatively new YouTuber who has quickly gained a lot of traction due to his excellent videos teaching and more broadly communicating topics related to chemistry and science in general. Joey was incredibly kind and provided a lot of great advice for people just like myself who are looking to develop a new podcast or YouTube channel. We also had the chance to speak on a number of topics that are more chemical in nature, and it's clear from watching his videos and from our brief conversation that Joey is wise beyond his years and is a person of great integrity and value. It was a pleasure to get the chance to speak with him, and I hope you find the conversation to be as valuable as I did. So without further ado, Joey Newton. First of all, thank you for having this conversation with me.
Thank you for having me as a guest. I appreciate it.
Of course. My channel for the time being is quite small, and you've risen to power quite quickly, it seems, so I definitely appreciate you taking the time. The first thing I wanted to say is just to give you a little bit of context. I mentioned it briefly in my email that my own background is in chemistry, and this is actually the first episode that I'm doing where it's sort of centered around chemistry and physics and science in general, so it's exciting. But I am a lowly master's degree holder, and I haven't quite risen to the full PhD experience. So just to set your expectations as far as where I'm at, I did just my bachelor's and my master's in chem. And then my master's degree, my thesis was it was a lab focusing on semiconductor nanocrystals. And then my project specifically was related to spectral electrochemistry. So it was essentially using electrochem to induce different exciton states and then characterizing them spectroscopically.
Yeah, that's interesting.
That's where I come from. Yeah. You mentioned that I think, I don't know if it was in a recent Q&A or a different video that I'm confusing, but I think you mentioned that electrochem was one of the things you saw with the greatest potential for growth, or the thing that was most exciting to you.
Yeah, I think electrochemistry is one of the areas that is going to get more attention moving forward. I think the first problem that Phil Barron and IKA have addressed is the development of a product that makes electrochem reproducible. Because I don't know if you're familiar with the history of electrochem, but Phil Barron's group did a few papers on it. Like, electrochem has been around for over 100 years, but they hadn't found a way to make it super reproducible. So people would try and go reproduce procedure. Maybe it would work. Maybe you'd have to spend a month or two optimizing it to get it to work again. And this was an issue that even Phil Barron's group ran into. People were emailing them saying, like, hey, this chemistry is not working. Why is that? And so they decided to tackle this problem with IKA and make this instrument. And I'm planning on doing a video about it at some point, and I've connected with the IKA people, and so hopefully that will come out eventually.
Yeah. Wow, that's exciting. So is that an imminent video, or is that something a little bit longer term?
I'm hoping within the next few months, sort of thing. Like, I have a couple projects ongoing that it involves dialogue back and forth with someone, and after some amount of time, those get done eventually. So, yeah, it's just a question of priorities and stuff. Yeah.
Mm-hmm. And you were mentioning before we got recording that you had just spoken with Niall Red and presumably the broader chemistry YouTube community. So how was that?
Yeah, so I have a small Discord group that I connect with the other ChemTubers on, and I'd started it because I just assumed something like this existed. And there's this really good YouTube book. I'm going to immediately go off on a tangent and say there's this really good YouTube book from this guy named Daryl Eves. He's the first thing I introduced to anyone I'm talking to about YouTube stuff, because it was really helpful for me. He's one of the people behind Mr. Beast's growth and the growth of several other bigger channels, like Matt Pat, if you're familiar with Game Theorists, Legal, if you've watched law videos. And so he's got a lot of experience on the platform, and he's really good at what he does. And so there's this really good information there. One of the things he's talking about in the book is how to connect with other creators in your niche. And so find the group of people if they exist. If you don't have a big enough niche, then maybe other creators locally around you. And so that didn't exist. So I just started that with a few of the smaller ChemTubers, and over time that gained people like Chemical Force, Explosions and Fire, and now we have Nile Red. So yeah, it's good. It's like a community, we talk about some like chemistry ideas, video ideas, demystifying YouTube, all that sort of stuff.
Sure.
Yeah.
And I guess the flip side of that, I saw one of your, I don't know if it's at this point still your most highly viewed video or somewhere close, but the video you made addressing the Action Lab. Uh,
Yes. Second
maybe
most
when
viewed.
I've not, yeah. So is that something you plan to do in the future? More sort of commentary criticism within the community?
So I think that type of thing does do a service for viewers. The challenge is how to do so in a way that is constructive. People in his audience had already kind of roasted him ahead of time, but he didn't do anything to address it in his comment section. He didn't like pin a comment or anything until after I made the response video. But once the response video happened, like he kind of had to. So
Hmm.
I'm glad that he did. He did take some responsibility for it, even though it could have been a little bit more. He uploads a lot of videos, so I think it's easy for stuff to fall between the cracks. And I'm sure that I've also made mistakes. I think the most recent mistake I've made was in a tier list talking about atrazine, which is a chemical involved with frogs changing their sex if exposed in tadpoles. And even that seems like there's a bit of doubt whether or not there's legitimacy to that because the science hasn't been easily reproduced. So I'm not claiming to be flawless here and not make mistakes, but I think when mistakes are made, it's important to address them if possible. Yeah,
Yeah, for sure. And I guess as long as the content creator on the other side is receptive and willing to actually evaluate whether the criticism is valid, then it's all good fun.
and it can be done ahead of time, right? Like for big videos that cover a topic outside of your expertise, I really encourage people to run that past people first. It might delay the video by like a day or two, but that can save you a lot of grief later. There's a reason we have peer review in the first place, right?
Exactly. And the other big difference is that once it goes out, it's out. I mean, how many people are even going to pay attention to any revisions or corrections that are made? Probably a
Totally.
pretty small percentage. So, for
Yeah,
sure. And I wanted to get into, before we get too deep into the conversation without starting sort of from the beginning,
sure.
when I was going through your channel, it seems like you started by making intro to organic chemistry videos, and
That's
then
right.
that sort of naturally transitioned into some more like, let's say, broadly more appealing content, things that even if you're not a chemist or studying chemistry that you might find interesting. So, was that the goal from the beginning, or did that just sort of?
So initially, I was making lecture videos because I saw the niche on YouTube as having room for high quality lecture material that talks not only about the normal material that textbooks discuss, but also the contemporary methodology. And so I'm a methods chemist. If I have to make a molecule, I think about what's the current way to do it that's the best. And many textbooks lack some of the contemporary methods, such as like a DMP oxidation, which is a Des-Martin priodenane oxidation.
Mm-hmm.
Oxidation and a lot of textbooks don't address this. A lot of the channels that make YouTube organic chemistry videos, they tend to address more with like specific problems or broad concepts, but it's most of the time just rehashed stuff from textbooks, not so much like practical, here's what people are currently doing now. So I wanted to have like good explanations in conjunction with some like real examples similar to what you see in Reaction Flash, which is this app that Reaxis has made that's free. And uh, and kind of incorporate that into a style of video where it teaches the concept, it explains the mechanism, and you're not really cutting out any of the important steps in between. And I also wanted to do it from my own perspective from the ground up. And so that was kind of where I started. And that was initially like the scope of what I was going to do because I was like, well, I have this expertise. I need to do it in this way because this is the most important thing I can do. And after a few videos that were more entertaining, which were I think the best smelling and the worst smelling compounds I've made in my PhD, those just did so much better that it's kind of hard to not make videos that are more appealing and more entertaining. And I think
Mm-hmm.
if the audience is big enough, I can spice in some more expertise and maybe I'll put some more time into lecture videos at a later date. And even looking back at the lecture videos now, it's like I want to redo them already because it was just so it's like it was good at the time, but in retrospect, I'm just a lot better than I was then. So yeah,
Sure. Well, that was still pretty recently, right? Those videos were, if I'm not mistaken, 4 or 5 months ago. Those were
yeah,
uploaded.
yeah. But
So you're
I've
just saying in terms of feeling comfortable recording in front of the camera and doing
yep.
doing the whole rigmarole, I guess, right?
Yeah, and the quality of the microphone and yeah, just everything. I did zero editing for ages. Like I did almost no editing for any of those for like the first 30 or
It's
40
impressive.
videos. Yeah, and I was like this is fine. And if you listen to one of my more recent videos compared to the older ones, the pacing's a lot better. There's a lot of annoying sounds that are in them and it's just like it's harder to listen to the older videos for sure. Yeah,
Sure. So is that something again? Is that more of an imminent or a longer term type of plan? Because
definitely
those are
longer
fun,
term.
even if you're not Okay, cool. Okay, cool.
So yeah, so we can talk more about YouTube stuff. So it would just
Hmm.
hurt channel momentum. So yeah, so you have a bit of experience now making YouTube videos. I think you'd mentioned in a previous episode of your podcast that you had made some other chemistry related channels when you were younger. Is that right?
Yep, exactly, exactly.
Um,
I had a channel called Splurge in Science. Now most of the videos are unlisted. The channel still exists. I'm not even just saying this because we're recording. I sincerely don't remember the name of the channel presently.
okay.
Although I certainly could dig it up, and I will for you. But I think it's still one of the top how to make chloroform videos. Like a few of the
The
videos got a
first
few hundred
haloform
thousand
bleach and
views.
acetone.
Yeah,
Yeah,
exactly,
yeah.
exactly. It's a few of, I mean, things that are suitable for mostly suitable for a high school student. Like I isolated bromine. Like that was a fun little project, and sealed it in an ampule and left it in my room, which gives me
Sketchy,
nightmares
but
at this
better
point.
than
Yeah,
not in
yeah,
an ampule, that's for sure.
yeah,
Yeah.
exactly. And thankfully I also marked the level, so I was able to assure over time that the ampule was in fact sealed correctly, and nothing was slowly leaking into my room. So that was good.
That's good.
Um, but yeah, so I did that for uh, maybe a year or two, but then just fell out of it upon university, and this is my return, my attempted return to YouTube, essentially.
Yeah. So the I'll give you some encouraging things about YouTube. So this is also applicable to anyone listening to this. So it isn't a matter of luck anymore. Like previously, because big channels were just big and there wasn't personalized recommendations, you would just get recommended like this is what's popular. Watch the thing that's popular, and you wouldn't get targeted like videos. But
Mm.
now, if you go on YouTube, everything's tailored to you, right? If you're looking at the sidebar, if you're looking at the homepage, that'll be totally tailored to you, right? Your subscription feed is based on your subscriptions, and you do see every video from every creator there. Now, I don't know what happens if you're subscribed to like 300 channels. If you see everything there, you're supposed to, according to YouTube, that's the case. But there's some contradictory information out there about that. But for normal people who are subscribed to like 50, 100 channels, maybe fewer, should be fine. You should see everything in there. So it isn't a question of if you'll get discovered. The question is, are you producing content people want to watch? And then it's just a matter of time, sort of thing. So if you're consistently producing content that's appealing to people, it's like best off in this case where you can have some of your personality revealed. I haven't done this as much in terms of like dialogue on my channel. I had one video
Mm-hmm.
with Tom from Explosions and Fire, and eventually I am starting a podcast relatively soon. So we'll
Nice.
see. Stay tuned for that.
Mm-hmm.
But this type of content where you can get to know people's personality is far more engaging for the viewer, which is why podcasts are a thing, right? Like it
Sure.
makes a lot of sense.
Exactly. Mm-hmm.
And so that's like one of the first things is have some personality in your content. Then instead of trying to make videos for the algorithm like a lot of people do, you have to make content for people because that's what the algorithm's chasing is. The algorithm's really good now at chasing what people want to watch. So if you're making videos that people want to watch, you've got the same goals as the algorithm, and so you should match fairly well. And then if you've got YouTube's interests in mind, are you making the types of videos YouTube wants to encourage? That works too. And so it has to be a combination of engaging to the viewer, but also something that you want to make so that the viewers can see like, hey, this is a thing you're actually passionate about. So it's a tight balance. But regardless, even for this podcast format, I definitely recommend that YouTube book called The YouTube Algorithm. And there's some other good resources from that guy on YouTube, but the book is just distilled information. It's like super, super
Okay.
good. Yeah.
No, I'll definitely check that out. I mean, I can definitely benefit from all of that. But it's good. That's obviously a very good thing to hear from my current position.
Yeah.
And but I guess one of the questions I wanted to ask you closely related to this is how big do you think, like, what's your evaluation of your audience? Is it mostly people with a true expertise in chemistry who are following along for a bit of a proper chemistry community, or do you think that it's much more broadly appealing than that?
I definitely think there's a broader appeal. It's hard to have a good idea of everyone in your audience. There usually will be buckets people fall into, and based on the age range and what you hear people say in your community, you can get a feel for that. So the better you understand your audience, the better you can be at making content because that's like a really valid form of feedback. So I would say a significant amount of them are maybe like 10, 20%. That might still be a little bit on the high end. It might actually be higher than that, like 25, 30. It's just hard to know because some people will say, like, yes, I'm a researcher, but does that mean you're a chemist? Does that mean you're a researcher in another field? I can tell you that, like, roughly 50, 60% of my audience is like 18 to 34. And
Mm-hmm.
that's like that makes sense because it's younger focused. Um, but there's people who are high school students, there's people who are in undergrad still, and what do you call someone who's in undergrad, right? Like they might be an undergrad researcher, but that doesn't mean that they're like going to become a researcher. So it's like,
Hmm.
yeah, I'd
I
say
see what you're
people
saying. Yeah.
like the best metric I think for that is looking at other channels that your viewers watch. And so I'm hitting the type of people who watch like Lock Picking Lawyer, Adam Ragusea. There's some science, but it's also
Interesting.
interesting, and some personality, that kind of stuff.
Yeah.
Yeah.
No, that makes sense. So from I mean, the trajectory for you is looking quite good at the moment. Is that
Thank you.
affecting your career outlook?
So yes, the complicated thing is, well, what is it exactly that I want to do? So I haven't defended my PhD yet. That's something that should be figured out in the next few months. Hopefully, I'll have an idea of when that is. I'm just writing up at the moment. But my initial goal was, okay, I'm definitely going to go into research. I definitely want to become a professor. I want to teach like a research group how to do chemistry, right, and kind of get all my ideas out there and train people in science. And so that was initially my goal since kind of like late undergrad, especially early grad school. I'd already kind of known that I wanted to do this in undergrad. And so I don't want to talk too much about like postdoc prospects because stuff could still change, and I don't know
Hmm.
whether or not I'm going to do that yet. It's just kind of like everything's up in the air. But I had some really good opportunities on the table. But like, what is my end goal? My end goal is to communicate science to as wide of an audience as possible. And initially, I didn't even think about YouTube being an option. It was like, okay, I guess I go become a prof. If I'm really successful, maybe I'll have hundreds over time of grad students, like let's say over a full career. And if I can do a really good job training those people, maybe they'll train another like several hundred people each, like in an ideal world, right? A little bit
Hmm.
idealistic, but it's like kind of the idea.
No, that's fair. I think that's fair.
Yeah. And well, I'm kind of at this point now where, well, why would I do that when I could have a way bigger audience online, right? And it isn't just like I want to affect more people, but if I have something useful to say and I can get feedback from those people and I can talk about more useful topics more quickly, it's just like unparalleled. And if you make the best resource on something, like you can just dominate everyone else. And the really cool thing about YouTube, I don't want to toot my own horn too much here, but like you said, I've only been doing this like 5 6 months, and I have like the most viewed videos in research organic chemistry on the platform, like when I do my monthly video. And so I take that as an indicator that people were like dying for research organic chemistry
Yeah.
content on YouTube. And so like it's doable, and it doesn't have to be me, right? Like if anybody else does this, I'm happy to encourage it because it's about at the end of the day getting people to have exposure to high quality information so that there's as little time of scientists wasted as possible, and also for just people more broadly, right? Like I think anytime people are spending with the wrong idea, like just a wrong idea, it's just such a loss, right? If we have that information out there, let's just make it like understandable, communicable, and just spread it to everyone as quickly as possible, and then talk about it like in formats like this. So
No, for sure.
yeah,
I'm almost surprised there isn't more of a pool of people already doing it. I mean, I'm very happy for you that you were one of the first to really fit the niche, and I imagine there will be more. But like you said, at the end of the day, it's very personality focused. There's some people who will just gravitate towards more of you as a person or the way you might happen to phrase or articulate certain things, and there's definitely room for many different content creators. But it's exciting,
yeah.
and I wonder, do you know of anyone else in a similar position to yourself? Any new content creators in the chemistry space?
So yes, but I guess it depends on like which sub niche. So in the research chemistry space, or let's just say the pseudo research educational space, like I'm just trying to like put a distinction here between all of the people who do organic chemistry lectures who are smaller and not focused at all on a research perspective. It's
Mm-hmm.
exclusively like teaching
Mm-hmm.
versus people who are trying to say like, hey, if you're a researcher, this content's for you. The biggest ones in my mind would be like synthesis workshop. So that's Matthew Horwitz. He's working in his industry. I'm drawing a blank on what company, maybe Pfizer. I'm not 100% sure. His channel's probably the next biggest research organic chemistry channel. He has really high quality talks from the actual authors of these papers. That's like a really good resource I'd encourage people to check out. I've talked with him, and he's starting to take some of this YouTube information as well, so that's helpful.
Nice.
Casual chemistry is another really good one. He does like working through mechanisms for problems. I connect with him on Discord as well. And the other one is simplifying synthesis. And simplifying synthesis is a little bit smaller, but Same sort of idea, covering research paper topics and communicating it to people. But we're all relatively small. I think the main reason these channels aren't growing faster is just lack of transparency of information between creators and between YouTube. I think YouTube could have more of a role of teaching people how to do YouTube. It's in their best interest too, so I'm not sure why there's not more help on that front. And you just slowly like find your way into the circles that will help you succeed if you're trying to succeed, because good creators tend to encourage other data-driven creators to improve. So that's like a positive thing. Yeah.
No, absolutely. So just to close this loop, for the time being, you have several months at least to sort of still keep everything open,
Yep.
finish the PhD, consider the postdoc opportunities. But if the channel continues growing at any similar rate to what it is now, I think it's probably fair to say, it sounds like you're saying it's more likely that you'll really dig your teeth in there and see if you can just make a full-time career that way, right?
Yeah, it's so the hard thing is it doesn't have to be an either or, right? Like I could decrease upload frequency and do something else as well. If it's like solely money driven, YouTube's going to make me more money than any alternative just way faster. And you might be like
Mm-hmm.
that's crazy. It is crazy. YouTube's a really good opportunity for creators. Um, even if you're not a creator, if you have ideas about YouTube for anyone listening out there, the one thing I will say is it's easy to view the YouTube creator relationship as like YouTube's exploiting you. They're taking half the money, they're 45%, whatever. But it's not like an exploitation situation at all. It's extremely symbiotic, because how are you going to find like a million people to listen to your stuff? If everyone you knew gave a link to your channel to everyone they knew, you'd still have like a tiny fraction of the power that YouTube does. So YouTube is really good at finding not just people, but people who want to watch your stuff. So it's a really good relationship. Figuring out advertising for your videos too is also just incredible that Google does that. Because if you've ever worked with sponsors, I'm sure at some point your podcast will have sponsors. There's a
Fingers
lot of
crossed.
logistics.
Mm-hmm.
um, and figuring out when this is going to be ready and when are you going to get paid, and there's all that. YouTube, you just watch a video and they've already figured it out.
You just
And
deposit it in your account at the end
yeah,
of the day, yeah.
it's incredible. So it's not an exploitation relationship at all. It's like a really good deal. And sometimes people get salty about that. It's like, well, I could have more money. It's like you could have 100% of less money, or you could have 50% of more
Exactly.
money. What would you prefer?
Exactly. I
So
think people neglect to consider really what it takes to operate a platform like YouTube. I mean, just the
yes,
server space alone, forgetting all of the other things. And that doesn't make them immune from criticism, but yeah, I tend to agree. There's a lot of people who are very quick to just get very salty very quickly, but
totally.
I think it's pretty good. Overall, I can't really complain. I mean, I'm not, and I say that from the outside at this point, not somebody who's actually benefiting from that 50%.
Time
Also,
will
let
come.
me also just throw something out really quick because I forgot. I brought out all the stops for this one. I brought out the periodic table chart
Oh, right on.
and made sure to highlight the palladium because
Oh, perfect.
upon discovering your channel, it became apparent to me very quickly
It's the
that
most
seems like
noteworthy
one of your
element.
first merch directions is throwing
Yeah.
some palladium T-shirts and that chemist palladium's
Oh, there
con.
you go. Yeah. Palladium, I have a love-hate relationship with palladium.
Yeah, that was one of the things I wanted to ask because you say that it sort of takes a lot of the fun out of
Yeah.
the game of chemistry a little bit, but at the same time, you've also made comments that you're a very pragmatic, sort of functional chemist. So if anything, I feel like you might tend to say, "Who cares if it removes the fun? It's just excellent. It's just one of the most useful things for your research."
Yeah, I would say both are simultaneously true. So, from like a problem-solving perspective, you can just palladium and then optimize away till you get the result you want. Like you could do that for almost any reaction, right? CH activation, maybe you need a directing group, right? Like there's carbon hydrogen for people who are not chemistry experts. Palladium is basically the philosopher's stone, and it can do anything. It's just a matter of ligands, which are like these molecules that bind to the metal to change how the metal behaves, or a matter of screening conditions, right? Conditions could be the solvent, the temperature, the time, etc. So palladium is a very OP, overpowered element, but it's kind of not fun that way. It's like, oh, we saw this little thing happening as a side reaction, and then we made it happen more. And then the whole paper that they finally write on it is written as if it was like planned. It was like, no, you just noticed a side reaction, and it happened to be useful, and then you spent like a year or two optimizing it. That's fine. There's nothing wrong with that. Like that's how discoveries happen, serendipity. But I think it's less cool than some of the reactions that are like, oh, here's this clever disconnection and here's this cool creative trick. It's like, yeah, palladium. It's like, okay, another palladium paper, fine, whatever. Yeah.
Sure.
It
Yeah,
like
no, that's fair. That's fair.
my real beef is people will put those into high impact journals like Jax or Ongavon and be like, wow, we did this ortho CH functionalization of this hydrogen with a directing group, and it's like, this is so great. It's like, yeah, but like, come on, like, that's, no one's getting fired up about that. Right? Like, it might solve
Yeah.
someone's problem, it probably does, but no one's getting fired up about it the same way that they would be about some other cool reaction where there's like a cascade domino reaction sequence, whatever, something cool. Yeah.
Yeah, no, there's. I feel like there's a few things like that. The other one that comes to mind is graphene. Like if you just if graphene is in the paper, it's just
Oh yeah, instantly accepted. Yeah.
exactly. Which is like you said, there is some degree of a basis for that, but it's also gets annoying, gets old quite quick, quite quickly.
Yeah.
So there's a number of sort of in the weeds type of questions. I mean, hopefully not too much so that it loses some people's interest, but um, some more context about myself. One of the main reasons that I decided to step away from a wet chem environment is because of the health and safety concerns. And I was told that it's obvious, first of all, of course, and then I was told that repeatedly. But until I started really getting my hands dirty in my graduate school experience, did I only become confronted with just how dangerous the environment can be. And I'm speaking as somebody who the focus was physical and inorganic. So compared to OChem, I think it's really nothing. Um, so is that something that really weighs on you? I mean, you make a lot of videos talking about health and safety in one context or another, but does that stress you out? Because it really it really weighed on my mind quite a bit.
So it does, and it did. I think I used to worry more about it. My issue is more with, like, the bone I have to pick with a lot of my videos is things aren't as safe as you think they are just because you can buy them as like a regular person, even, right? Like, we're talking about organic chemistry, but think about what you can buy at like the grocery store or like even a Walmart. You can
Mm-hmm.
get some pretty nasty chemicals, and a lot of the time they're not even labeled. Like in Canada, some of the cleaning products or detergents we get now, they won't even tell you the ingredients on the bottle. They'll be like, oh, you can look on our website. And I'm like, that's the wrong direction. I
Really?
think that's like, the infantilization of the West. It's like this whole idea of not making adults capable of making their own decisions, so you make it for them. It's like, that's not. I'm not a fan of that. So I
No.
think the opposite approach is better, right? Inform people, the younger the better. Teach them what it is they're working with, what the safety hazards are, and then encourage responsible behavior. Um, so that being said, a lot of the chemicals you work with just at home could be potentially really dangerous, right? Like a lot of the stories that I cover in my channel are like somebody mixed bleach and ammonia and they made trichloramine and people think it's mustard gas, but it's distinct. But that doesn't matter because don't mix them because that's dangerous.
Mm-hmm.
Or mixing like vinegar and bleach, just dangerous stuff that makes corrosive chemicals that people are not prepared to deal with. So do I think there should be stronger controls over chemicals? No, I think just better education and then holding people responsible and making sure that they're accountable is probably the right thing to do. So for like an OChem context though, yes. And if you're working with really sketchy chemicals like hydrogen cyanide, any azide, dimethyl sulfate, iodomethane, I would be like cognizant of that, and you treat it seriously with respect. And that doesn't mean you don't work with them because they are tools, but it means that you're like responsible. When this is kind of getting more like tangential, but maybe still useful, I used to care a lot more about me and my safety than like what you're actually trying to accomplish. So well, what are you trying to accomplish for all of us, kind of thing. So this is kind of stuff I haven't got into, but it's more like what are you hoping to accomplish in a lifetime? And you could protect yourself from these hazards. Like maybe you're never going to have a drink of alcohol in your whole life because you think you're going to get liver cancer. And my attitude is like, if you're going to get to the end of your life and die of cancer, you've done a pretty good job mitigating risks, and you can still mitigate every single risk and you'll still die of old age. And well, what is dying of old age, right? Senescence, like some part of your body wears out. Epigenetic despecialization, or the telomere stuff that people talk about. But
Mm-hmm.
like, well, like, what do you want to accomplish in a lifetime? Are you gonna like live in a bubble your whole life, or are you gonna take known risks for known benefits, right? A risk reward type thing. And that risk isn't just a risk for you, it can be a risk for others. And that is a major thing I want to highlight here and in those videos is Like you can do a thing that's dumb and it can like mess your life up, and that's bad and you should avoid it. But if you're doing something that can affect lots of other people, don't you dare just cavalierly do that, right? Like the chem pit. I don't know if you saw the one episode about the chem pit, but someone's like, I've been
Yes.
putting all my chemicals into a pit. It's like, yeah, don't do that. Please don't do that, because you don't know the extent of who it would affect. And kind of related to the correcting science action lab thing, more related to this video I did about these Novex solvents, are like people just dipping their hands in them. They're like, oh, it's fine, it's non-toxic, and it's like, well, we have shown in our own research that these react with these other things, and there's this similar anesthetic that causes like kidney disease. Probably these things aren't as safe as you thought they were, and maybe
Hmm.
someone should be looking into this for the benefit of all of us, instead of you just saying like, well, we don't know yet, smiley face, it's fine, just like keep using it, keep buying, please. And I think companies also need to have our best interests at heart, right? Like they do have their own interests, but I really dislike this concept in medicinal chemistry, pharmaceutical chemistry, where you don't ask a question you know that they won't want you to ask. I don't like that, because that is like lack of responsibility, right? Yeah.
No, absolutely. So how do you think we should move forward with that? Is that just a regulatory issue? Is that sort of just a cultural norm type of thing? Like you mentioned sort of the infantilization of the West. Is it just up to us to sort of demand for certain information to be present sort of ubiquitously?
I think there should be transparency of information, but I think people should also just be more ethical. And I know it's kind of like not an optimal solution, because some people will think, well, some people are going to be unethical regardless. But if you support your friends and families to make ethical decisions, and especially your friends, right? And you encourage people to do the right thing, people tend to get better, which is why, like, you hear people saying, like, I've been hanging out with all the wrong people. It's like, well, there's this impact of your social circle around the types of behaviors you make. And you see this sort of thing with like vaping or people who excessively consume certain drugs. If their whole circle is constantly doing it, you're just in an environment where it's easy to do that. And so, similar to the thing we see in academia, where colleagues won't support a colleague who speaks out against something, they'll just kind of have no spine and let them get thrown to the wolves because they want to protect themselves. You need to have an environment where people support people who do the right thing. And I think having a platform on YouTube helps with that. And I think this whole concept of podcasts, intellectual dark web type stuff, helps a lot with that, because people go, okay, there is a group of people who actually want to do the right thing. There is a group of people who want to get better. And I think from a company standpoint, you want to have that as part of your core values, and people will tend to prefer companies where that's the case. And if companies mess up, take responsibility, right? Like with, I don't want to be too harsh on 3M here, but like simultaneously, while 3M is in a lawsuit from some like environmental contamination issue, they're posting on their Twitter like being committed to sustainability, and like it's like, come on, like just
I
be
know.
honest, right? Like be consistent here. And you know people appreciate it when you come clean. Yeah, maybe you did something wrong, and I think it's better to own up to that than just hide it under a rug. And I'm not saying I'm perfect either. I'm sure almost everyone's made mistakes, and there's things people haven't dealt with, but it's important to try and be better than we were
No.
yesterday.
Absolutely, especially on the scale of corporations where
Yeah.
one little slip up isn't just this one-off thing that you can move on from it. That alone can be detrimental just to thousands, tens of
Yeah.
thousands, millions. So yeah, it's pretty scary. It's really pretty scary. But you're right. I think that is something. I think people in general, to circle back a little bit, people do have a tendency to say safe or not, as if everything that comes in a product that we interact with in any capacity, it's just every ingredient is fully understood about all of its health effects, and it's just not the case. Yeah,
Yeah.
and it's. What do you think? I want to get your opinion on things like there's a lot of products that are sort of the same but opposite, like pH water, alkalized water, for example, and a lot of these things that try to almost their marketing is that they are highly scientific, or the amount of times I've seen something that says made with special nanotechnology, or something to this effect, just these sort of
Yeah.
meaningless phrases.
So I really hate those. I haven't gone too like militant against them on the channel
Hmm.
yet, but they
Yet.
grind my gears. Yet. No,
Hmm.
yeah, yet. The thing I want to do here is like dismantle them, but like in a very robust way and in a really well done way. And like one of the classic ones is antioxidants. I've ripped on them a little bit on the channel, but someone was saying that they got an ad on one of my videos, which was like for C60 fullerene cream as an antioxidant. I'm like, I don't think you should be putting C60 in or on your body anywhere. And they
No.
had all sorts of products that one might apply to different areas of their body. And I'm like, what the heck? Like, people need more education about this. And you hear it everywhere. Like to say like antioxidants don't do anything is almost like taboo. And so it's like, well, what do you mean when you say don't do anything? You can't
Yeah.
just claim because it's an antioxidant it's good. That's not a clear thing. What do you even mean, right? It's just like the language and the framework is wrong. So I do want to come out more against those types of things. Uh, but a lot of these issues get politically charged. It's not too bad with like antioxidants. Like there's people who will be a little bit more woke and be like, oh, like these are a good thing I want to do. But then you get to things like when is something actually green? Is doing
Hmm.
something in a recycled, reusable way always the like lowest impact activity? It's like that's not super clear. So there's much bigger issues here, and so I'd probably pick them like one at a time and try and work through them. Yeah,
Sure,
I don't know if I
absolutely. And
answered
that
the
one,
question.
no, absolutely, absolutely. And one thing that I hope ends up making that list, the one that probably grinds my gears more above all else, is energy and
Yeah,
how badly misused that term is. And obviously, it gets to the extreme where, at a certain point, sometimes you're just talking about crystals, which are doing doing who knows what
oh,
supposedly.
that
So
energy. Yeah, yeah,
yeah, exactly. Exactly. That's the point. Is that somebody with a proper background will not even it will take a moment to even identify what I might mean, what I might be referring to in that context.
yeah,
So,
yeah, for sure.
okay. So I just to make sure we get to a few different topics, I'll shift gears a little bit. One thing I wanted to ask you, especially because your focus is largely like wet chem oriented. I took several courses related to quantum chemistry or computational chemistry or however you want to categorize it. And a lot of people in that field seem to think that we might be in the last stretch, within reason, of having the wet lab be the primary means of doing our chemistry. For example, I mean they envision a future in which most of this is done computationally and just
Instead of
purely with, and then
yeah.
of course there will always be the final verification in the lab. But do you agree with that from the organic chemistry standpoint, or do you think that's wishful thinking?
So I wouldn't be comfortable making that broad of a statement about it. I'd say certain areas, like I think you could digest a lot of reaction discovery using physical chemistry. So I've talked about this one set of parameters a little bit on my channel, specifically more in the lecture videos, less in the more recent stuff. There's this group of nucleophilicity and electrophilicity parameters. And nucleophilicity is this idea that you have electron density, like something like a nitrogen or an oxygen, and you're going to give it to something else. Some sort of electrophile will accept that electron density. And this guy named Mayer, Mayr, his group looks at the kinetic parameters of those nucleophiles reacting with those electrophiles. So this would be like, let's just say something like trimethylamine reacting with some sort of carbocation. So they're SN1. So positively charged thing reacts with negatively charged thing. How quickly does that happen? And you can draw a lot of trends from that to infer reactivity of different nucleophiles in general. And so the bigger the list of nucleophiles you've looked at, and you can even look at like trends between substituents on these, like you add a chlorine here, you add a methyl group, whatever, how does that change the kinetic reactivity? And you can look at that with electrophiles too and nucleophiles. And so if you have a really big library, you can look at the resulting rate using these parameters to predict whether or not the reaction would happen like slowly, quickly, or like never within the heat death of the universe sort of thing. And there's kind of like this range that we want where we have normal, predictable reactions that will behave a little bit. And maybe that means you need to heat them a bit, maybe not. And I think a lot of that can be broken down just with having better data sets. And so
Hmm.
I like if I was doing physical chemistry wet lab, I would just be churning out like more numbers for that. And I think that's actually really useful, even though it seems like boring and not that romantic. It's really useful. And it was a selling point for one of our papers that wasn't even SN1. It was SN2, which is like there's two steps. Like nucleophile comes in, it gets really close, and then the the leaving group leaves. It's still one step, but it's an inferred reactivity because it's not directly SN1. And so this was like a key selling point for like this is why these things react in our paper and this is why these other ones don't. And like all the reviewers love that. And anytime I talk about it, people love that because it's like there's a clear trend between like why certain things work and certain things don't. And if you look at like any reaction you've learned in OChem and you, like, let's just say a Michael acceptor reacts with a nucleophile. You can predict which nucleophiles will add and which ones won't, depending on the N parameter of the nucleophile and the E parameter of the electrophile. And then suddenly, like, tons of stuff that are named reactions are like, this is an electrophile, this is a nucleophile. The numbers are right, it works. And you can just predict that for tons and tons of stuff. And it demystifies a lot of chemistry where you might learn this type of thing could happen, and it doesn't happen sometimes, and it does happen other times. And you just memorize the ones that work, and you know, these ones don't. And that's like, okay, fine, you can do that, but it's way better when it's intuitive. And it's intuitive when you can break it down to that, like, how big is the E? How big is the N? Do they cancel out and form something between like 0 and a positive number? If yes, then it's going to be something you can do in a reasonable time frame. And that's I think really important for teaching, because it demystifies a lot of this stuff, but then it also makes it like possible for wet chemists to have benefits from the physical chemist. So coming back full circle, I think certain stuff could be, if there is enough computational power, you could probably model stuff more effectively. But right now, there's, I think, too big of a gap still in terms of how quickly stuff can be modeled. Solvent effects. I'm not a computational chemist, so I don't want to like speak too much into this, which is
Yeah,
like
sure.
why I haven't talked about it too much on the channel. But like, let's say you want to get something modeled with an iodide. People don't do it. It's got too many electrons. It's like too hard to model. Could someone do it? Sure. Could you do it in like a lower, less valid modeling tool? Yeah, sure. But like, you lose some of the utility doing that. So yeah.
Sure. And again, I don't want to linger on this too long because I know you prefer to speak on your area of expertise, but there are DFT and a lot of other different quantum chemistry techniques that are ambitious about maybe getting to the point where they can work with many more electrons than they're comfortable doing with these supercomputers basically now. Do you see that being likely? Because as far as I'm concerned, and again, I'm no expert in the field either, so this is just sort of a broad speculative statement, is I'm not particularly optimistic.
I'm not either. There's too many interactions going on, and like, part of the problem with this is we have so many ideas of what's going on in a reaction that are just not, they're not complete. Like, we don't really think about what's the solvent doing to the molecule, but that's absolutely changing everything all the time. And if you screen a reaction with like acetonitrile and you switch to dichloromethane, maybe it works, maybe it doesn't. It's like, well, they had to be doing something for the reactivity to change. So like, well, what is that? And can this tolerate water, and why are we not? And if there's like a trace amount of an impurity in there, that impurity might catalyze a reaction. So I think there's too many factors going on to fully model properly. Could we get some useful data from modeling? Absolutely. Would it completely outright remove the wet chem? No. However, what I will say is I think a lot of automation could take the place of the wet chemist. It's just a matter of getting machines that can do the things we need to do. And there's some labs that do this already. And I don't know how much you've looked at those robots that can like automate reactions. The part of the problem is, like, when you ask someone to assess these ideas, they might not have a complete understanding of the different technologies that exist right now. So when they try and imagine whether or not this is possible, they'd say absolutely not. But there's lots of crazy technologies that exist that people are using even in industry that academia people just aren't aware of. So you can do a column by robot, and everyone should be doing that anyway because it's reproducible, which is like something we should be pushing for. But there's these things called phase separators. So you can separate two different organic layers, or an organic layer and an aqueous layer, with a phase separator. That just like outright only lets one of them pass through. There's these like robot probes where you can detect whether or not it's a liquid or a gas, and so you could just like take that but not the gas layer, and you could take one layer which is like aqueous versus non-aqueous. And so like, these technologies exist, and then it's just a matter of like moving the liquid around from vessel to vessel. So I think a lot of the wet chem in a well-funded lab, maybe the technology needs to improve and the cost needs to come down. Definitely the cost needs to come down. But I think a lot of the wet chem work could be replaced by automation. And I think if you ask chemists what it is you want them, what they want to do, like if you ask me what do I want to do, like, do I like doing some of the wet chem stuff? Absolutely. Do I like doing columns anymore? No. Like, I've
Yeah.
done hundreds and hundreds of columns, and like, yeah, there are neat tricks and figuring it out's fun, but like, I've done enough columns. Like, could I do another
That
1,000?
type of thing gets old, no
Yeah,
question.
yeah, but it is satisfying when you get it to work. Like there are like, ha, I beat this. So there's like, uh, there's enjoyable things to overcome, but a lot of the wet chem work is like repetitive, especially in methods chemistry, which is also what I'm saying like is my background. But the cool thing is, like, I want to try this new reaction. I want to see how this behaves in this new environment. Like that, those one-offs are the most fun thing to try. Or tuning out like what weird side reactions happen, what products form. That's the most satisfying thing from my perspective, even if it's not necessarily high impact, because it's interesting and I like interesting stuff. Yeah.
Sure. So from that, do you think that you'll go a little more of, let's say, the Nile Red route and do some chemistry yourself for your videos, or will you do you think you'll stick speaking, giving commentary, giving lessons, talks,
Yeah,
etc.?
I would like to do some practical chem on the channel. I don't have an immediate plan to do that because there's kind of a high cost to entry for that sort of stuff, especially if I want to do it in a really safe manner. One of my like long-term dreams that I've talked about with the other chem tubers is I'd really like to have like an influencer lab. So there's this whole idea of an influencer house where people come and move and then they like work together. But this sort of thing for like a chemistry context would be really cool because the barrier to doing online chemistry is like either you're just doing stuff in your backyard or you're doing it in some fume hood that you make yourself. Whether or not that's ghetto depends on who you ask.
Mm-hmm.
But I think we can all agree that a legitimate fume hood is superior. And if you're going to do research and you do research in any context other than a lab, you won't be taken seriously. So, like, tell me where the safe point is. So I have thought about this sort of thing, but the cost of doing that is really high, and it's something that it's a dream. So it's like a thing I'd consider doing long term as one of the like big projects I want to tackle. Hopefully, I would be doing some practical chem before then, but utilizing university resources for personal products or for projects rather is not something I want to do. And I think Tom's model for that has been really good. Right? Tom from Explosions and Fire
Mm-hmm.
is
Mm-hmm.
you don't mention your university whenever possible, and you don't film stuff in your university whenever possible. Now that being said, I haven't done wet chem for like around a year now, so I'd like to do it. Even though I hate running columns, I'd love to run a column at some point. Um, and there are cool tricks I'd like to share with people that haven't been shown on YouTube, and some of them have here and there, but like just doing that in a way that's like useful and succinct would be fun. So like there's good ideas, and I'm instead of just doing them myself, I'm giving them to other chem tubers to do, and I'm fine with that because like at the end of the day, I just want to see good ideas get made rather than it doesn't have to be me doing it. I'm happy to give ideas away. Yeah.
Sure. So you're thinking the idea is more along the lines to assist professional chemists, like tips and tricks along those lines, more than doing just sort of fun,
Ah,
visually
both
engaged,
both
or
are
I guess
both
both.
are good. Yeah. So it could be helping professional chemists, but also just showing people what's possible is also really cool, right? The research context is you don't really just get to like screw around and do cool reactions, but that's exactly what I want to do, right? I want to have a feel for which reactions are good reactions, which ones aren't. And the fact that you can make that into a video is pretty incredible, right? Um, it, and in retrospect, I wish I filmed every reaction I did in my PhD work because that would have been so much content and it would have been really cool. There's like a lot of cool reactions, and now it's like, oh, I wish I did that. But you know, you learn, and
Maybe
I
maybe
can,
motivation to do with the postdoc then in that case,
yeah,
for content, for more
yeah.
than
But then
anything
the
else.
conflict of interests there, that's the
Yeah,
problem, right?
exactly.
Like it's hard. So anyway, but like yeah, if the postdoc supervisor was cool with that, that would be something I'd consider doing. But there's cooler reactions that I would like to just show, and so you can't always do those in a research context. Like yeah, yeah. Anyway, I won't linger on the point any longer. But yes, I'd like to do some practical chem at some point. But I don't want to get like delusional to the point where like I think this needs to be shown, therefore I need to do it. Right? If there's something more useful or more interesting I could do, I'd like to do that. But I do enjoy doing synthesis, and I would like to do some synthesis videos for sure.
No,
Yeah.
absolutely. A shared lab space with that, really, it's sincerely brilliant. I mean, so you vocalized that already to the broader community? I feel like that's something they would jump on
Yeah, it's
quickly.
it's the cost, right? Like I think the only way it makes sense is if it's like a multi-channel network or
Hmm.
there's some other sort of like structure in place where people can come and use it. There'd need to be like a regular lawyer on retainer making sure like everything's safe and legal, that there's no potentially edgy compounds being made that are not like controlled. So
Hmm.
there's a lot of like logistics involved, and the biggest logistical challenge at this point would be like cost and then convincing people that it's worth coming and shooting there. But you could imagine like constructing a whole lab from this perspective would be really awesome, right? Because you could set up the whole fume hoods and everything so that it makes sense for filming, right? It doesn't have to just be like off the shelf fume hood. Like you just spend a bit more money and set it up so that you can actually like film stuff and do it properly. Like that would be really cool. So that's like one of a few big dream projects I have, but can't imagine that would happen probably for at least the next 5 years. But we'll see.
Sure, but even in 5 years, I mean, that would you made it properly at that point if that ever becomes realized.
Yeah.
And so again, jumping around a little bit, you touched on this, and this is a little bit more of a common direction, but you kind of touched at the idea of basic science research versus sort of just chasing the funding and a little bit what's popular. Do you think because everyone who's spent serious time in the lab is familiar that basic science really ends up being the most fruitful work. I mean, if you look at the Nobel Prizes, a huge portion of them were just purely serendipitous and were things that were just curiosity driven. Graphene is one of them. CRISPR was another. You know, a lot of this great work is done after hours, purely recreationally. Do you think there needs to be different channels of funding to encourage that type of work, or do you think that it should always be left up to the researcher to sort of pursue that after hours?
Yeah, so it's a bit complicated. So the funding structure is complex because you have funding that is from the government, and so you need to spin a project in a way that makes sense. And you're right, like the interesting, cool projects people work on are usually like a thing you're doing on the side while you're working on this main project. And side projects are exactly like the cool thing that take off always. Like in my experience, the side projects are almost always the interesting thing, and they eventually grow and become the cool thing. Right? It's like there's this quote from a chess grandmaster. I'm not a huge chess person, but this is a good quote. It's like, when you see a good move, look for a better one. And I really like that, because when you're working on a
Mm-hmm.
project, it's like, do the most important thing possible, right? What do? You aim, and then you redirect, and then you aim, and then you refocus, and you just keep doing that. But at some point, you have to make publications, right? You have to write it up and get it done. And so that's where I struggle. Even like with videos and stuff, it's way easier to start like 40 projects than it is to finish like two. So it's a challenge. So for the funding side of things, it's complicated because if you're getting funding from industry, you sometimes have freedom. Like I wouldn't strongly say like you have no freedom if you're getting funding from industry. I think it depends on your relationship, what the terms of your agreement are, and what sorts of freedom they've given you. I think the way it works for like non-science, non-researchers, like let's just say for like a creator just decides what's going to work, and if it's a business, they can reinvest in their own business, right? So like if I want to like make better quality videos, I can get a better camera, which is something I hopefully will do soon. If I want to make better videos, I can have better quality audio, and so it's like I can reinvest, and there's a direct incentive. Now, if you want to do that in research, like if you want to do something that you believe matters, then you can do that. But oftentimes, like people come expecting their cut, and that might be reasonable, right? Like if a university comes and they want their cut, maybe that's like 40%. Maybe the university is really greedy and they want like 90% or all of it. It's like, well, that's de-incentivizing innovation in a way that someone would personally be able to benefit and be more motivated to complete. It's like, I think people can get greedy, and sometimes that makes people reluctant to pursue these sorts of projects. Or you have a situation where someone has a company and they don't publish anything, right? Some companies do. You see like OPRD, which is like a journal for researchers in medchem who are like actively, well, not just researchers, but like people in medchem who are making new molecules for a purpose. Like maybe it's a drug, maybe it's a compound that might become a drug, and they're just seeing. And you do sometimes get reports there, but there's way more molecules in their libraries than you even know exist, like in the public literature. And I know this because I've done a collaboration with a company before, and for certain substructures of molecules, they would like share their part of the library of it, and it's massive. And lots of these are not in the literature. Like they have molecules that don't exist. And this is even from an organization that is open about some of their stuff. So it's hard, right? Like how do you decide what to invest in? Well, you can invest in things that you've agreed to do, like contracts, whether that's with a company or like for a grant, or you could do some stuff on the side. And I think having some freedom to do stuff on the side is important. And I think for supervisors, it's important to not just like stomp that out. But I do understand that it's important to complete projects you start to the capacity that you can. Now, there is the sunk cost fallacy, right? You said you're going to do this, and so you could either do this, spend 3 years, and get a bad paper out of it, or you could just say to the funding agency, hey, we didn't do this, but we already have been doing this really great other thing. Here's why it's great. And hopefully the funding agency is receptive towards that. And I think as long as the people judging and the people in those oversight roles are encouraging the type of behavior that they ought to, And as long as the researchers are being honest and open about this, I think that's a good system, right? As long as nobody's trying to like cut people as much as possible and they're trying to overinflate the importance of what they're doing or justify why they couldn't get it done. I think if people are being honest, it should work. Yeah.
Surely, but what's your take as far as how much is that actually happening? Because I agree, if those two conditions are met, I would have the same conclusion. But I think I might be a little more skeptical than you might be in terms of both of those.
Yeah, the big challenge is everybody thinks that their paper belongs in a high impact journal. The journals, the way they're currently structured is such that like if you want to find the most impactful paper in organic chemistry of the last month, you can't do like where do you find that? Right? Like you just can't. And
Yeah.
so that's
Hmm.
like a really frustrating thing from a structure perspective. I know I'm kind of like dodging it, but I'm going to come back here.
No, it's okay.
Um,
Don't worry. Don't worry.
yeah. So I like this is why I started doing this series for like important papers in organic synthesis, where it's like, okay, someone else did the work for you. Me and a combination of people in my Discord went and looked through the papers. These are the ones we came up with. Here's what you should pay attention to this month. But the structure moving forward should be more like, you know, these are the organic chemistry journals. Like maybe depending on the impact, a panel of people will decide whether it's in like A, B, or C, and you just do that. And then you can find the important paper in the right place. That might be indexed and showed in some other like news feed. They can curate that to the person who's reading, but that makes more sense in my mind than something like Jax, where Jax just publishes from several different fields, right? Like at the moment, Jax has the most high impact organic chemistry papers. Entirely, no. Like you do have Nature and Science occasionally, and other thousands of journals that have sometimes noteworthy things. But I think if we just like put things in the right boxes, that is a lot more useful for people in that field, and then we can rank order that either into like some sort of category system or there should be some sort of metric for the journals. And I know people who are emerging professors in organic chemistry and they share the sentiment. So hopefully we could do something about that at some point. But we're talking about overhauling a system. And a lot of the stuff in the existing systems are good. Like, I'm not saying that just because some stuff about it's bad, all of it's bad, right? I think it just makes sense more to have things in a logical way. You can go to this box, you know it's in it. Okay, so that being said, the way things are currently done is you're chasing impact factor. You don't ever want to publish something in a journal that's too low of an impact. And every academic in my field like is like this, right? Like you always want to apply to the higher impact journal even if you get rejected. But there is usually like a little bit of accountability. Like if something's a JOC paper, you won't submit it to Angevanta Chemie. So
Hmm.
so that's like good. But people who are less knowledgeable, it's like, well, I've never had something in this journal. I'm going to submit it there anyway. It's like, okay, like your prerogative, but you're just kind of wasting your time. And I think this comes back to the honesty piece. Like, how important do you think it is? Like, you know, you have to somewhat detach yourself from your research and really assess it honestly, right? So I think this is like the first bigger issue because this is also contaminated with this funding thing, right? Because the funding body goes, well, have you been publishing in high impact journals? This work that you said mattered got into this lower impact journal. Maybe they don't care about the impact of the journal, but in my opinion, they probably do, right? I'd be happy to be corrected if that's not the case. I do think number of publications matters a lot more. Maybe having one publication or a few publications in a high impact journal also matters compared to like not having publications. But because this is contaminated, like the funding is affecting like where you want to publish, it kind of makes the whole system corrupt to an extent, right? Because you can't be honest about where you want to publish stuff. So people are worried about losing their funding and like maybe they have a family at home and then if they lose like their job, it's like it's all connected, right? So it's not a super clean problem to just sort out and address through like one snap of the fingers. It's complex, so it needs a complex solution. Yeah.
Absolutely, and I've given it a lot of thought myself in terms of just if I could just snap my fingers and make any change I wanted. I honestly don't even have, and I've talked to many people about this, and they, in general, most people are on the same page where I can't even imagine a restructuring that would be more or significantly more beneficial. It really does come down to just everybody playing their role in, like, let's say, a benevolent fashion. People just
Yeah.
need to take locally behave as they ought to, basically. So
Accountability.
it's
Yeah.
it's it is tough. Yeah, it's really tough. But and is that pushed you away from academia at all? Because that was part. I mentioned the health and safety. The other part was just the endlessly frustrating bureaucracy, and then just the publisher perish sort of mentality.
I know people in like I have peers that are not planning to go into academia because of this and not just the publisher pairs, but also just the fact that it's like sometimes described as like a swamp of like people just
Mm.
trying to virtue signal rather than trying to do what's right and not having a spine, not standing up for what they believe in. But I think the issue here is like, if you want to be the person who's doing the right thing and you're leaving the field because you don't think it's right, all that's doing is it's like removing all of the good
Concentrating the.
from it. Yeah, you're just concentrating the bad.
Mhm.
So if you care about, the academic institution, you need to, be the man of the house. You need to be the one who goes in there and like takes responsibility and makes it good and says what no one else is saying, because how is it going to get better? It starts with individual accountability. And so I think in general, like whether it's like in your house or in academia or your company or whatever, or your community, right? Take responsibility, do the right thing, model appropriate behavior, and if someone corrects your behavior and they're trying to be constructive, listen, right? And hopefully they're right, and hopefully more people will tell you when you're wrong so that you can improve faster. And so I think it's easy to get disheartened by a couple bad actors, and I do think that there are many instances where academia and institutions have been overly harsh on individuals, and instead of trying to side with the individual because of PR reasons, they just like, fire them or whatever. It's not a good situation. So I think the institutions need to have a bit more of a backbone too to stand up for their faculty. Yeah.
Yeah, absolutely. Well, I think we should close out there because we just hit about an hour, and I think that the tone of that felt perfect for wrapping up.
Perfect.
So really, thank you so much for coming on. I hope everybody enjoys this conversation, and for the two people who are watching me and not you, please go check out that Chemist channel. I'm sure you'll enjoy it very much if you've made it this far in the conversation. So, thank you again for coming on.
Thank you very much.